Hi, welcome. Today we are going to calculate the areas of parabolic curve. These are the triangles in which one side is parabolic to 2 degree, 3 degree and 4 degree, and this is 1 degree. Now we are going to calculate their areas. So A1 is the triangle first and A2 is the triangle second. Considering their one side is h height and the other length is b. Now since it is a right angle triangle, so A1 is equal to A2 and its area becomes equal to half of its height and length. So this becomes the area. Similarly, in the second case, you can see that this area is somewhat less than A2, and this is due to the concave inward of the curve which bisects this triangle. It is curved at 2 degree, and also the one side is h and the second side is b. Now we are going to calculate its area. So A1, as we can see that this is less than A2, so A1 becomes equal to 1 by 3 of BH, and A2, since we can see that it is larger than A1, so this is equal to 2 by 3 of BH. So this is the simplest way to calculate the area of the triangle, which is not bisected by a straight line, but it is curved by 2 degree. It is parabolic curve. Similarly, in third case, we can see that the curve has been curved at 3 degree, and this can also emphasize that A2 is more than A1. This A2 of third case is more than A2 of the second case because this is concave outward by 3 degree and this was concave outward by 2 degree. So A1 becomes more or less than this A1 for second case. So it becomes 1 by 4 of BH and this was 1 by 3 of BH. The denominator was less here, but the denominator here becomes more. So the value becomes more minimized here. And similarly, A2 is equal to 3 by 4 of BH. You can see here the denominator increases by 1 digit here and the numerator also increases by 1 digit. So it means that A2 of the third case will be more than A2 of the second case. If you can type this in your calculator, then it will give more value than the second case. Also in case number 3, 4, so A1 becomes more or less and A2 becomes more larger than the case number 3 as it is due to the parabolic curve which has been bent by 4 degree and this was by 3 degree. So considering its dimensions as h and b, so A1 is equal to 1 by 5 of bh as it was 1 by 4. So the denominator increases by 1 digit once again. So A1 becomes more or less than A1 of the case number 3. So A2 is equal to 1 by 4 of 4 by 5 of bh. So it becomes more larger than A2 of the third case. Now if you want to cross check the areas, then simply assume B is equal to 1 meter and H is equal to 1 meter. So total area becomes A1 plus A2, which is equal to half of uh, 1 meter and 1 meter, as we have assumed that B is equal to 1 meter and H is equal to 1 meter. So A1 is equal to half of 1 meter into 1 meter plus half of 1 meter into 1 meter. We have also taken this triangle plus this triangle, so which is equal to 0.5 meter square plus 0.5 meter square, which is equal to 1 meter square. Similarly, for second case, you can assume both the height and length equal to 1 meter. So the total area will be equal to A is equal to A1 plus A2 equal to 1 by 3, which is this one. 1 by 3 into 1 meter and 1 meter. This 1 meter and 1 meter are actually the B and H as we have assumed is equal to 1 meter here. Plus 2 by 3, this is 2 by 3, which is the factor which is to be multiplied with the area of the triangle to calculate A2. So it yields a result of 0.333 plus 0.6671 meter square. A1 is equal, A is equal to, this is the total area. The total area of this rectangle or this square is equal to 1 meter square. And similarly, same is the case for other rest of 3 and 4 cases. 3 and 4 are these cases. So there are some notes you have to bear in mind, except the case number 1 where both the areas are same. In this case, A1 is equal to A2 because it has been bisected by a straight line here, a diagonal, and while in all other cases the areas A2 are concave outward, so it will be a more area than A1 which are concave inward, as I have also told earlier that A2, A2, A2 and A2, all A2 areas are concave outward. So it will bear more area than A1.